The final read to me recording that I will be doing for this unit is on motors and generators. I hope you took this opportunity to do the motoring on lab. I also provided links to the PhET labs that you could do instead. Both this lab, the series and parallel circuits, can be completed in a PHETT lab that I had sent links out to in the newsletter, appropriate for this week, as well as this activity here. The labs are really important for deeper understanding about what we're learning, so please do not miss this opportunity. You will be on your own, and it's very important that you complete the model problems and the unit review before taking your unit assessment, so you won't be surprised at how you do. Lesson 9. Electric appliances in your home make all kinds of daily work easier. Garage door openers, power tools, battery-operated toys, and fans are all powered by motors that work because the forces exerted by the electromagnetic magnets. The motor uses electrical energy to exert forces that cause motion, thereby producing mechanical energy. I'm going to repeat this because I know that you will see this again in an assessment. The motor uses electrical energy to exert forces that cause motion, thereby producing mechanical energy. You will also discover the same electromagnetic forces that turn electrical energy into mechanical energy can also generate electrical energy out of mechanical energy. The, the large amounts of mechanical energy used to rotate these turbines can generate enough electricity for an entire city. What makes the blade spin on an electric fan? The combined effect of electric currents and magnetic forces turn electrical energy into mechanical energy. Anytime an electric current flows through a wire, the current produces a magnetic field. Engineers use this phenomena to build motors, such as ones powering a fan. These motors rely on the forces of magnetic attraction and repulsion to transform electrical energy into mechanical energy of movement. Let's take a closer look at a simple electric motor. In the previous lesson, you built a simple motor with its basic components, a battery, a wire, and some magnets. The on-screen illustration shows how the motor transforms electrical energy stored in the battery into mechanical energy of a moving wire coil. The electric current magnetizes the coil, which then turns the coil's magnetic field is repelled and attracted to the stationary magnets. Although their basic components are the same as the simple battery-operated motors, larger motors provide more power, doing more work each second. A wide variety of electric motors is used to power any number of mechanical movements. A spinning fan, a turning drill bit, a winding chain of a garage door opener, and the cutting gears of an electric can opener are all powered by electric motors. The motions of these tools are limited only by their mechanical soundness and by their need for electric current. To maintain an electric supply, most electric motors are simply plugged into a wall outlet, while battery-operated motors can be run on rechargeable batteries. When you built the electric motor, you saw that the rotational direction of the coil could be reversed by a change of magnetic polarity. It is also true that the entire energy transformation of the motor, creating mechanical energy electrical energy can be reversed. Electric generators transform mechanical energy into electrical energy. In the illustration on screen, you can see there is no battery power to magnetize the coil. However, by applying a mechanical force to turn the rod, the coil becomes magnetized and generates an electric current. This is the basis of electric generators that people use when there are power outages. The electric current that is generated runs through wires to power the light bulb. So it basically reverses the process. To generate large amounts of electricity, generators rely on powerful sources of mechanical energy. Many power plants use high winds, steam created by burning coal, or large amounts of rushing water to exert enough force to rotate giant turbines. This is your turbine right here. The turbines provide mechanical energy to the generator, which transforms it into electrical energy that can be used to power entire cities. Please take a minute and do a review for this lesson. It was short, but there's lots of information that should be understood. I'd like you to draw an illustration of an electric motor and be sure to include all the parts necessary to make the motor. This activity is very helpful for your upcoming ILEAP test. Both renewable and non-renewable energy sources are used to provide electricity to people of the world. So go ahead and click on this link that would be in your OLS, or go to your student pages and complete the charts that are here. You'll see a list of renewable resources and non-renewable energy sources. Make sure you go through these questions and answer them briefly or discuss them with a family. Well, that's the end of Lesson 9. All that you have left for this unit is to do the model problems and the unit review. You will then be ready to take the unit assessment. If you have taken the time and opportunity to fill out your student pages, then you will be ready for this assessment.